Now, the Arrhenius definition is great. However, it didn't include a lot of things that were known to be acids or bases. So the modern definition is the Bronsted Lowry definition, and in a book you'll probably see that O with a slash through it because of whatever language Mr. Bronsted came from. I can't remember it this time. So acids are defined as hydrogen ion donor, which is the same as the Arrhenius definition, just phrased a little bit differently. Here's where we have a different one. The base is a hydrogen ion acceptor. Notice it does not need to have an OH in its formula. So this will include everything under the Arrhenius, but then it includes some extra stuff, mostly bases. Now this is important. You have to have the equation because you have to be able to look at what is donating and what is accepting a hydrogen. And we are going to identify conjugate acid-base pairs. So if we look here, NH3 is a pair with NH4+, because the pairs are only going to differ by one H+. So see NH3 going to NH4+, added an H+. So NH3 is a hydrogen ion acceptor, which is why it's a base. Now, if we were to go backwards, and NH4 plus is going to NH3 minus, it's now donating a hydrogen, which is why it's an acid. We use the terms acid and base on the left of the equation. Conjugate on the right. So we look, H2O is partnered with OH minus. Okay, not quite sure how, there we go. And H2O is donating an H+, which is why it's the acid. If we were to go backwards, OH minus going to H2O would be gaining it. That's why it's the conjugate base. So we look here, HCl is donating the hydrogen. That's what makes it the acid. H2O this time is accepting the hydrogen. That's what makes it the base. And then, of course, the things on the right, you've got to look at the equation going backwards. But conjugate acid always pairs with base. So conjugate base always pairs with acid. You always have one acid in one base on each side. So once you've gotten one, it's pretty easy to figure out the other. H3O plus is called the hydronium ion. It's when a hydrogen ion attaches to a water. And this is a very interesting property of water. It can be an acid or a base, and that's called amphoteric. We will see a very few other things that can do that. So try this. So the first thing you have to do is figure out what is a partner. Well, CO3 2 minus and HCO3 minus have to be partners. Now this, you'll notice it's getting a hydrogen. It also had no hydrogen to begin with, therefore it doesn't have one to give away. So there's your base. So this must be, I'm going to abbreviate here, the conjugate acid. Well, once you know one, you know that this has to be the acid, but we can check it, and H2O does indeed donate a hydrogen to become OH minus, so OH minus is the base. OH minus is always a base. H3O plus is always an acid.